Now the determinant of the matrix. Determinant is the value. Each square matrix has a unit square value called the determinant of A. It is denoted by the determinant A. Suppose the matrix is 2 by 2 order and find the determinant of its. Then the value of determinant is the difference or the multiplication of the diagonal element. It's the simple process or to find the value of determinant in the second order determinant, the difference of the multiplication of the diagonal element. Suppose the 2 by 2 order determinant is given here, and the diagonal elements in the first diagonal element is the element is 1 5, in the second diagonal element is 2 6. The value of determinant is the multiplication of the diagonal element, the difference of the multiplication of the diagonal element. The first diagonal element is 1 5, 5 and the 5. The second diagonal element is 6 to the 12. 5 minus 12 is equal to minus 7 is the value of the second order determinant. It is clear, everyone? In the same, the first diagonal element is A11, A22, and the second diagonal element is A12, A21. The difference of the diagonal element. The first diagonal element is A11, A22. The multiplication is this. The second diagonal element is A12, A21. The difference of the both the diagonal element multiplication element. This is the value of determinant. The example here, the 2 by 2 order determinant. The value of determinant is the difference of the diagonal element. The first diagonal element is the 3 and 2, 3 to the 6, 1 minus 1, 1, so 6 minus 1 is equal to 5. It is clear, everyone? Now we come to the 3 by 3 order determinant. If the order of the determinant is 3 by 3, then find the value of determinant. Then the value of determinant is the sum of product of their element and their corresponding cofactor. And the formula is A11. If the A11 is the, if we expand in the determinant in the first row, then the value of determinant is A11 and the corresponding cofactor is C11, plus the second element of determinant is A12, first row second column, and the corresponding cofactor is C12, and so on. The last element of the row is A1n and the corresponding cofactor is C11. Then the value of determinant is the sum and product of their element and corresponding cofactor. This is the 3 by 3 order determinant value. It is clear, everyone? Give the some example. Suppose the matrix is 3 by 3 order this and find the value of determinant. First we calculate the, as we expand in the determinant in the first row according, then the value of, then we find the cofactor of first row C11, C12, C13. After then we calculate the value of determinant. A11 is the first element and the corresponding cofactor C11, plus A12 is the second element and the corresponding cofactor C12, A13 is the last element of the row and the corresponding cofactor C13. Then the sum and product of their element and corresponding cofactor is the value of determinant. It is clear, everyone? This, the main important issue is if you expand the determinant according to the first row. Some students say that I expand the determinant in the second row, and some more students say that I expand the determinant in the according to the third row or any particular row and column. If you expand the determinant in any particular row or column, the value of determinant is always same. There is no difference between you expand in the according to the first row, according to the first, second row, third row, or any particular row or any particular column. The value of determinant is never changed. It is clear, everyone? It is your choice. If you take, if you expand the determinant according to the first row, you are take the first row and expand there. If you take the second row, third row, or any particular row or any particular column, the value of determinant is always same. There is no change. Okay. Now we come to the practice question. These are some practice question of the determinant in solving the word problem, word file. These are the question. Find the value of determinant if A is given. This is the 2 by 2 order determinant, and find the solution of the 2 by 2 order determinant. This is the matrix. First we form in the determinant form. The first element is 4, second element is 3, next element 5, and again is 12. The value of determinant is the difference of the multiplication of diagonal element. The first diagonal element is 4 and 12. Then the multiplication 4 into 12 minus the next second diagonal element is 5 3. The 4 12 is the main diagonal, and second is diagonal element is 5 3 5. Then the multiply the diagonal element 5 3. The value of determinant is the difference of the multiplication of diagonal element in the second order determinant. Then 12 4 ja 48 minus 5 3 ja 15. The value of determinant is 48 minus 15, 33. Answer. It is clear, everyone? Now we come in the next question. In this question, the find the value of determinant. The matrix is given here. First we note down in the determinant form of the given matrix. The value of determinant is the difference of the multiplication of the diagonal element. Now we multiply the first diagonal element, main diagonal element is 2x plus 3 and x plus 1. Multiply both the element. 2x plus 3 multiply x plus 1 the difference minus 2x plus 1 x plus 2 now the difference of the multiplication of the diagonal element, the first diagonal element 2x plus 3 multiply the second diagonal element x plus 1, the second diagonal 2x plus 1 multiply by the x plus 2. Now simplify in the next step. Multiply one by one each element in the both the bracket. 2x multiply by x, then the value is 2x square. 2x square 2x multiply by 1, the value is 2x multiply by 1, the value is 2x. 3 multiply by x, the value is 3x. 3 multiply by 1, the value is plus 3, bracket closed. Now they come in the second bracket multiplication. Two x multiply by x, 2x square. Two x multiply by 2 plus 4x. 1 multiply by x, result is x. 1 multiplied by 2, result is 2 plus 2. Both the bracket multiplication is complete. Now we solve this bracket in the next step. Open the bracket. The second bracket, the sign is minus. Then all the element is sign change when bracket is open. Minus 2x square minus 4x minus x minus 2. Now simplify. 2x square cancel out from 2x, both the sign of opposite and value is equal. Then 2x square cancel out 2x square. 2x plus 3x is equal to 5x, and 4x minus x also minus 5x, both the sign opposite and value is equal. Then cancel out 3 minus 2 is equal to 1. Then answer is only 1. It is clear. The value of the determinant is 1. It is clear, everyone? This is the simple question. Now we come in the next question. Now we solve the determinant according to the first row and along to the first row and along first column. If you calculate the value of determinant according to the first row, first column, the value of determinant are always same. It is clear. If you solve the determinant according to any row, any column, the value of determinant is always same. But in this question, ask the value according to the first row and according to the first column. We calculate it. The part first, the value of determinant first be assume A is equal to the value of determinant note down the value of matrix and note down in the place in the determinant. Let us assume now solve A. Find the value of determinant along first row. Along first row. Value determinant according to the first row is determinant A is equal to A11 A11. The corresponding cofactor is C11 plus A12. The corresponding cofactor is C12. The last element of first row is A13. The corresponding cofactor is C13, C13. The value of determinant is the sum of product of the element and corresponding cofactor in 3 by 3 order determinant. If we expand the determinant according to the first row, if you take any row, any column, then according to the follow the same rule. Now we put all the value. First we calculate the cofactor C11, C12, C13. After then put the value in this equation. First we calculate cofactor. First cofactor C11, is equal to C11 first row, first column cancel out, then the remaining element, first row, first column cancel, remaining 1 6 2 8, 1 6 2 8. The value of the second order determinant is the difference of the multiplication of the diagonal element. The first diagonal element is 1 and 8, then the multiply 8 1 is 8 minus second diagonal element 6 2 is 12. The value is 8 minus 12 is minus 4. The sum of the order is even number, then the sign is no change in the minor. Now we will calculate the second cofactor C12. The sum of order is odd number, then the sign is negative before the minor. Now the C12 value is deleting the first row, second column, the remaining element 4 6 4 6 4 6 7 8 7 8. First row, second column element cancel out, and the remaining element 4 6 7 8 is the value of determinant. The value of the determinant of second order, the difference of the multiplication of the diagonal element. The first diagonal element 4 8 4 8 is 32. The second diagonal element is 7 6 7 6 is 42. The value of determinant is minus 32 minus 42 minus 10. Minus minus plus 10. The value of the cofactors C12 is 10. Now we calculate last cofactor. Last cofactor is C13. The sum of order is 1 plus 3 4. The sign is no change in the minor. Note down the value of minor. The value of minor obtained by the cancel out the first row, third column in matrix A. First row, third column, the remaining element 4172. Note down 4172. 4172. Now simplify the second order cofactor is the difference of the multiplication of diagonal element 4 2. The first diagonal element is 4 2. The multiplication 4 into 2 is 8. The difference. The second diagonal element 7 and 1. The multiplication 7 and 1 is 7. The value of determinant is 1. Now the cofactor is find out. Now put all the value. A11 is now from the equation first, from equation first, A11 is equal to A11 value is first row first column 5 multiply C11. C11 value is minus 4 plus A12 first row second column value is 9 multiply C12 into 10 plus A13 is 3 multiplied by 1 now solve the value. Five 4 is 20 minus 20. 9 10 is 90. Note down 19 here in the same position. 3 1 is 3. The value is 93. 90 plus 3 93. 93 minus 20 73. 73. This is the value of determinant of A 3 by 3 order. It is clear, everyone? This is the span to the determinant according to the first row. Now the second part is also calculated along with the first column. Calculate the value determinant according to the second column, first column. Now firstly, note down the determinant the value of determinant according to the first column. The first column element is A11. A11. The corresponding element is C11 plus the first column second row element is A21, A21 row is second, column is first, and the corresponding element, corresponding cofactor of this column is C21. The last element of the first column is A. The row is 3, column is first, A31, and the corresponding cofactor is C31. It is clear, everyone? Now A11, C11, A21, C21, A31, C31. The third order determinant is, the formula is same, the procedure is same, the sum and product of their element and their corresponding cofactor. Now this is the, take the equation second. Equation 2. Now first we calculate the cofactor. Find the cofactor first cofactor is C11. C11 is equal to the value of cofactor. The same value also calculated in error. Note down here. C11 means first row, first column, cancel out the remaining element. 1, 6, 2, 8 is not here. The value of cofactor is the difference of the multiplication of the diagonal element. This is the first cofactor value C11. Now we calculate another cofactor C12. C12, it means C21. C21 means second row first column element. Second row first column element cancel out, and the remaining element 9, 3. Second row first column element cancel out, and 9, 3, 2, 8. Simplify. The second, the 2, 1 is the sum of the order is odd number, then the value of the minor is negative. The value of minor is negative. Then the value is equal to minus. The value of determinant in second order is the difference of the multiplication of the diagonal element. 9, 8 is 72 minus 2, 3 is 6. Minus 72 minus 6 is 66. Now C31, calculate the value of C31. C31. The value of the element of C31, we cancel out the third row first column element, the remaining element 9316, note down here 9316. 9316. The sum of the order is even number, then the minus sign is no change. The value of the determinant of second order is the difference of the multiplication of the diagonal element. 9 6 are 54 minus 3 1 are 3. The value of determinant is 51. Now simplify. From the equation first, from equation first, from equation second. What is the equation second? Note down here. A11 is first row, first column element is 5 multiplied by the cofactor minus 4. A21 is the value is 4 multiplied by the C21 is minus 66 plus the last element of the first column is 7, so A31 is 7 multiply by the corresponding cofactor is 51. Now simplify in the next step. Five 4 are minus 20 minus 2 4 266 the value is 28 to 86 plus 357. We simplify in the next step. The value is 26. It is clear, everyone? This is the multiplication. 5 multiplied by 4 20. After then 4 multiplied by 6 66. 4 multiplied by 66, the value is 264, and the 7 is multiplied 51, then the 357. Now simplify. minus 20 in the next step. Minus 284 minus 284 plus plus 357. 264 minus now we calculate the next step. 357 minus 284, what is the value is plus 73. The value determinant is 73. Is clear everyone? And according to the expand to the first row, then also the value 73, and according to the determinant expand in the first column, also the value determinant is 73. Both the value is same. It is clear everyone? Now we come in the next question. The first question is, solve the value of x. Both the determinant are equal, then find the value of x. The determinant of the second order, first we solve both the determinant, then apply the condition of equality. It is clear everyone? The determinant is second order, then the value determinant is the difference of the multiplication of diagonal element. The first diagonal element is x and 2x, then multiply x and 2x, 2x square, 2x square. And the second diagonal element is 3 and 5, 15, minus 15. 2x minus 15 is equal to, now the second determinant is also second order. The value determinant is the difference of the multiplication of the diagonal element. 5 3 is 15 minus 5 4 is 20 minus 20. Now solve in the next step. 2x square is equal to 15 plus 20. 2x square is equal to 15 plus 20 is equal to 35, and minus 15 come in the right hand side, then the sign is changed, the value is plus 15, then 2x square is equal to 50, then the value of x square divided by 2 become in the right side and come in the divide to 50, then the x square is equal to, then x square become 25, the value of x, then x become 2 equal to 5. It is clear? Plus minus 5. and the value of plus minus 5, plus 5 minus 5. Minus 5. It is clear, everyone? This is the solution of the two matrices where is given equal. First we solve the determinant of both the determinant of 2 by 2 order by the difference of the multiplication of the diagonal element. After then apply the condition of equality, then solve the value is x is equal to 5 and minus 5. Now solve the second question. First we solve the determinant of second order by the difference of the multiplication of the diagonal element. The first diagonal element is first diagonal element is 2x, x plus 2 and x plus 1. Multiply both the diagonal element. X plus 2 multiply x plus 1 equal to and minus. Second diagonal element is 1 and 3x. Multiply 3x and 1 multiply 3x equal to second determinant of the second order. Then the value of determinant is the difference of the multiplication of diagonal element. 4 into 3 12 minus 1 1 is 1. Now simplify by the matrix simplify the bracket multiplication. The next step, x multiplied by x, then x square. X multiplied by 1, then plus x plus 2 multiplied by x, 2x, 2 multiplied by 1, then plus 2 equal minus 1 multiplied by 3x, then 3x equal to 12 minus 1 11. Now simplify this equation. X square plus x plus 2x 3x and 3x cancel out, 3x the cancel out, and 11 minus equal to 11 minus 2, then x square is equal to 9, then x equal to plus 3 comma minus 3. Is clear, everyone? This is the answer of the determinants in this question. This is the solution of this type of equation. It is clear, everyone? Now practice question based on the determinant is solved. Now we come in the Sarah's rule. This is the shortcut method to find the value of determinant or 3 by 3 order. This is the Sarah's rule and it is an important method. Ask the question directly, solve the given determinant by the Sarah's rule. In this question, first we note down the determinant of 3 by 3 order and repeat first two column. Repeat first two column. Note down. First we note down three columns given in the question. Column first, column 2, column 3. This rule is applied 3 by 3 order determinant. It is clear. First we note down three columns of the given determinant. After that, note down first two columns, repeat first two columns. Then the multiplication of the determinant of the 3 by 3 is the sum of the product along the sum of the product of the element along the diagonal descending to the right. Take the right side and the sum of the product of the element, and the difference again the sum of the product of the element along with the ascending order to the right. First we take the descending order to the right and sum and product of the element of the diagonal, and then we take ascending order to the right and sum and product of the element. Then we get the solution of this type of determinant by the Saras method. It is clear. For example, the matrix is given in of 3 by 3 order. First we repeat the first two columns 1, 4, 7, 2, 5, 8. Now according to the Saras method, sum and product of the element along descending order to the right. The right side, the first diagonal is 1, 5, 9. The product of the element 1, 5, 9. The again diagonal element is from the descending order from the right 2, 6, 7, and the last diagonal element in descending from the right hand side 3, 4, 8. The product and the sum is this. After then the 45, 84, 96. After then the ascending order. Now we take the ascending order from the right side. The first diagonal is 7. The first diagonal is 7, 5, 3. The second ascending order right side is 8, 6, 1, and the last diagonal is 8, 4, 2. It is clear, everyone? Then the difference of the diagonal is the value of determinant. This is the Saras rule. Clear, everyone? Some practice question of the Saras method solved in the Word file. Now come into the Word file. Find the value of determinant by the Saras rule. Clear? Now solve it. First we note down solve by Saras method by Saras method. First we note down the three given column. The determinant form, note down the determinant form. Now put the value of the given in here. First we note down first two column value. Now the value of determinant is, first diagonal element is 2, 3, 6. 2, 3, 6 plus in this method, student, the first diagonal element, now we take the second diagonal element multiplication and the third diagonal element in the addition, after then the subtraction of the right side value. It is clear? Plus the second diagonal element 171, 1 7 1 2 3 6, then 1 7 1 171 plus take the last column from descending order from the right. Last value plus 3, 5 and 2. Break it close. All three diagonal element is multiplication is complete. Now we come the minus sign and come with the ascending order from the right. 1 3 3 1 3 3 1 3 3 2 7 7 6 6 1. Now we take the value 1 3 3 plus 2 7 2 plus 6 5 1. Now simplify in the next step. This is the Sarasu. Multiply 2 3 is 6 plus 6 1 is 6 plus 6 6 is 36. 3 2 is 6 6 is 36. 7 1 is 7 plus 7. 10 5 2 is 10 plus 3 30 plus 30. Bracket close. Now we take the sign minus. Six 3 is 9 plus 28. 7 4 is 28 plus 6 5 is 30. Now simplify in the next step. Sixty-six plus 7, 66 plus 470, 73 minus 28 plus 30, 37, 67. The next step is the final answer is 73 minus 67, 6. Answer is 6. It is clear, everyone? First we take the descending order diagonal element and the multiply. The first diagonal element is 2 3 6, the multiply, then plus the second diagonal element in the descending order 1 7 1, multiplication, and the last diagonal element is 3 5 2 and the multiplication. First two column is repeat here and here also, then the take minus sign, and the now we taking the ascending order diagonal element from the right 1 3 3 plus 2 7 2 plus 6 5 1. 2 3 is 6 is the 36, 7 6 7 7 1 is 7, 7 1 is 7, the answer is 7. 5 2 is 10 into 3 30, the answer is 30. Note down here. After then 3 3 is 9, 4 7 is 28, 6 5 is 30, then the add 6 36 plus 7 is 43, 43 plus 30 73 minus 28 plus 7 is the answer is 37 67. The 73 minus 67, the result is 6. It is clear, everyone. This is the Saras method. Now the solve in the next question by the Saras method. Now the second problem solved by the Saras method. Note down the value here and write down here. Now paste the value. Now the last first two column repeat and the value is this is cancelled out. Again the last column in repeat, first two column repeat, last column is not repeat and the last value is delete from this matrix. Value of determinant is equal to, first we take the value from the right hand side, right hand descending order. The first value is descending order value, first diagonal element, first diagonal element. Now we take the second diagonal element, second diagonal element. Now the last diagonal element. Last diagonal element. Is equal to bracket 5 into 0 into